Welcome back, everybody. Today we're talking about percentages, and some of the basic concepts we'll be going over would be percentage basics, percent change, multi-step problems, makeup, discount, and compound interest. So first of all, some percentage basics and change. Um, a percentage is essentially how many parts you have per whole, so the fraction of the thing we're talking about, and that times 100. So if I have 1/5 of a cake, the percentage is 1 over 5 times 100%, and 1 over 5 is roughly zero point 0.2 times 100. That gives me a 20% share of the cake. Then there's like also a concept called percentage change. So when you have a percent change, that means how much you have changed relative to your original value. So for example, if I say I have $100 and now I got a 20% interest on it, so that 20% is my percent change, which essentially means that my P new, say P is my amount of money in the bank, minus P old over P old times 100% is 20%. For example, here, maybe my price went from 80 to 100, then someone might tell me that I have $100 now and I got a 25% increase. I got a 25% interest from the bank last year. Then I can simply calculate how much money I had there at the first place by simply applying this formula, and I can say 100 minus my P old over P old is equal to 25%, which we know can be rewritten as simply 0.25, which is divided by 100, and get rid of the percentage sign. And then we can say 100 minus P old is 0.25 P old. If you solve this, you end up with 1.25 P old is equal to 100. You divide 100 by 1.25, you get P old is equal to 80. So that's the kind of problems you'll usually see. Sometimes there might be a multi-step and compound interest problem. For example, you have successive changes. So if you have a compound interest, for example, if you have a simple interest, first of all, actually, let's break that down. If you have simple interest, then you get the same amount every time. So if you have $100 and you have simple interest of 20%, then every year you get a plus 20, plus 20, plus 20, because this 20% is being applied to here, what I actually deposited when I opened the account. But if you have compound interest, that's where things get interesting because now I have $100, I get plus 20 the first year, but now I have $120, and the 20% interest that I'm supposed to get from the bank is going to apply to this new capital of 120. So now the second year, I get 120 plus 120 times 20%. That is actually 24. So I end up with 144 the second year. So essentially, now we have a multiplication problem, whereas previously we were just adding the same amount every year. And the way you basically formulate them is for simple interest, you say I is equal to P, R, T. P is my original capital, R is my ratio, which is basically the percentage of interest that I'm getting, and T is number of years or something. It's going to be in terms of units of time. So it may be bi-monthly, then how many periods of 2 months have passed. So if 6 months have passed and you have bi-monthly interest, then you'll multiply by 3. T is equal to 3 in that case. But if you have compound interest, you write P, you have A is equal to P times 1 plus R over N times NT. And essentially, what we're doing here is the N is the number of periods per year or the number of times per year that this interest is being applied. So, for example, maybe, let me clear the board for you. Maybe per year, every 3 months, this interest is applied, this compound interest is applied, and I have a 5% compound interest. Then at the end of the first year, my total amount would be 100 if I deposited $100, because of course I don't have more than $100. Then we can say 100 plus R, which is the ratio or the percentage. So that's 0.05 for 5% interest. And we divide it by the number of times this is being applied, which in this case is 4, because this interest is being applied every 3 months. So that happens 4 times a year. And then we divide by NT. So that is simply 4 times 1 if we are looking for the amount of money that I have in the bank after the first year. So this T, the T is my number of years, and N is number of times per year interest is applied. Let's try out a practice question. The population of City A increased by 7% from 2015 to 2016. If the 2016 population is K times the 2015 population, what's K? So in this case, what you have to remember is this is a percentage change. So what it's saying is 7% is P new minus P old over P old. So we can rewrite it as 0.07 P old is equal to P new minus P old, which gives us P new is equal to 1.07 P old. And the quick trick to remember is essentially you have to add or subtract from 1. So if it's a percentage increase, if it's increase, percentage increase, it's 1 plus the change over 100, so whatever percentage change you have. And if it's decrease, it's 1 minus the percentage change over 100. The golden rule to remember would be using the multiplier method. Whenever you have increase, 1 plus rate. Whenever it's decrease, the p-factor is 1 minus the rate. And when you have repetitive successive changes, in that case, you just kind of raise that to higher powers, right? So if a 7% increase happens for 3 years in a row, then you simply start with the starting population. So if it's P of 2015 times, then you say 1 plus the rate, which is 0.07 to the power 3, because it happened for 3 years in a row, right? And in this case, see, we're not dividing by any n here because we are tracking changes per year. If we had, if we were tracking changes every 6 months, and that was say 0.3, then the same thing we would have to write as p old times 1 plus 0.03 over 2, because now we're doing it every 6 months, so twice a year, times 3 times 2. Sorry, to the power 3 times 2. So the golden rule, as I described, as I explained earlier, multiplying by the prefactor of 1 plus rate or 1 minus rate, depending on increase or decrease. And then if you have chain multipliers, that means there's successive change. So if you have the same, if you have growth or decay at the same rate, then you multiply by that same factor, the same prefactor, that many times, which is the same as raising that prefactor of 1 plus rate or 1 minus rate to the power of the number of time period essentially you have. So if it's annual, then just the number of years. If it's biannual, then you multiply that by 2, and so on. So as always, just keep practicing, keep improving, and I'll see you in the next one.